Thank you. Anyway, I will start. And then I came here last September, and then initially I thought I can improve my English here. However, I worked in the office by myself, so please forgive me for English. And then I worked with Mark and Linda from 2009. Yeah. And then, today's talk is, first of all, I would like to introduce by myself, and then background of presentation, and then about our camp, and then evaluation of our science camp. Sorry, this is my first time to use Mac for presentation. That's because I'm a Windows user in Japan, and then I heard over here everybody use Mac, so I bought Mac from Japan. And then actually I was here 1995 to do my doctoral work under Dr. David Ryan. Yeah, and I use GCM here. And my background is meteorology, actually. And I used to work for KO, and at KO I teach at senior high school and also university. And then I decided to move to university 2005, and then now I work for the very small liberal arts college in Tokyo. And then this is I came from, and then our university, we didn't have science program. However, from 2007, our president decided to start science program, and then they built this science building, and then this is my room, and then astronomical dome, and then weather observation, observatory. However, our university is very small, and then we didn't have science program, so nothing in our university. So I thought I want to do something, and then also high school students don't know about our science program, so I need to approach to the high school student about our science program. And then Japanese government try to promote science education in the United States, in Japan. And then there is several projects going on. And then this is one of the projects, science camp project to promote science. And then Japanese government pay for the lodging and then tuition, that kind of stuff. So we apply for that science camp, and then here is so many science camp, and then our camp is one of this. So our camp is supported by a kind of government project. And then this is science camp background. And then since I use GCM, and then I want to use EdGCM. And then actually, 1995, I use a specific SST model. However, for this EdGCM has predicted SST. That means this model is much better than model I use for doctoral research. And this is EdGCM project goal. I think they know about EdGCM, right? Yeah, and since we don't have manpower at our university, then I asked Mark and Linda to use this kind of documentation. Then I translated into Japanese. I made this kind of manual for the science camp.
A tremendous effort. Quite a lot of work.
Yeah, so we can easily start this kind of project. And then also at that time there is a built-in scenario, so students can use this kind of scenario to analyze result. And then we developed 3-day camp. Oh, by the way, I also use EdGCM for the university education. Surely, I'm teaching meteorology. Yeah. And then I set a concrete objective to understand the climate system, and then understand the global climate model, and then experience scientific process and to acquire scientific strategies, and then to develop attitude towards global environmental issue. I think very similar condition in United States. In Japan, there are so many skepticism about global warming, and then even for meteorology professor, they don't teach climate change. And then, if you look at the textbook for the meteorology, climate is, end of the book. So usually they don't teach that section. So we need to prepare for that kind of audience. So content of our science camp is, about we did lecture about climate literacy, like 1 hour on the first day. And then also field measurement. We need to teach not only the modeling, observation is very important. And then also, in Japan, weather forecasting is very difficult. And then 1 week forecast is, useless. So if such a condition, students think, why we can predict 100 years ahead? Since, besides we cannot forecast 1 week. So we need to distinguish between weather forecasting and the climate prediction, right? So we need to teach about weather observation. And then also, in the GCM, there is a theory, and then theory predicts the weather, right? So we need to, grasp that kind of idea to the student. So students need to, natural phenomena can be explained by the theory. So we try to provide that kind of experience to the student. And then, surely computer laboratory. And then also they need to experience about science process. So final day, they will have, chance to present their result. These are our timetable for our science camp. 3 days, however, first day is from the afternoon. That's because, our participant came from all over the, Japan. So it takes like a half day to arrive in Tokyo. And then we think they cannot concentrate to the computer desk work more than like a 2 hours. So we put, other activity in between the computer lab. And then, actually, our camp is supported by government, right? So, we got 38, 21, 27 application, and then we take every year 10 or 12 students from them. This is Japan, and then compared to United States, very small. However, this is 2,000 kilometers. So not, and then this is Okinawa Island. So our participants from Okinawa and then Aomori, Kyushu Island.
And how old are the students?
Senior high school students mean like 10, 11, 12.
Oh.
So grade. That means senior high school. Like 15 to 18 years old.
Oh, okay.
Yeah.
Sure.
Right. And this is computer lab, and then measuring pressure, temperature, that kind of stuff. And then this is laboratory experiment, and then this is final presentation. And then if I have time, I have lots of pictures. I will show you, and at the end of this presentation. Then these are final scenario. The second day evening, we will discuss about final project, and then like 3 to 4 students make one group, and then in each group, one professor advises the final scenario, and then these are final scenario, and then to run like 100 years, we need one night. Then these are, their final scenario. Then we are doing this camp as a part of our climate change education, also educational research. So we need an evaluation, and then we need a good instrument to evaluate our camp. And then there is a UK project about dissemination of the climate change. In this project, they use questionnaires and then pre-test and post-test, and then they will evaluate the change. And then we will show that climate change is happening now, and the student will answer strongly agree, neither, or that kind of answer. And then we will give same question at the beginning of our camp and the end of our camp. And then this is result, overall result. Before mean pre-test, and then after mean post-test. Red is strongly agree. So strongly agree increased from 61% to 79%, and then neither is decreasing. So we can get some kind of effect on student.
Yukimasa,
Yes.
For the students who are not really changing their minds,
Mhm.
did you have an opportunity to ask them why?
Not that kind of opportunity.
Okay.
Yeah. However, we have detailed data, and I came here in September, right? Yeah.
I have a question.
Yeah.
So, can you tell, like, the student who actually strongly agreed went to the other way? Or
Yes. Yeah, and then that result is overall result. And I since came here, I use statistics analysis on these data, and statistically, by total, is big significant difference. However, for each item, if you look at each item, we can get significant difference between only on the climate change is happening now. For other one, we don't get any statistical significance. However, if you look at into the male and female, this is female result. For female, 3 items are significantly, changed. So our participant is, very special, so we cannot generalize. However, maybe there is a difference between male and female effect of that kind of, this kind of opportunity.
Is it split evenly? Is it 50-50 male female?
Oh, only the first year, female is 6 female and 4 male. However, second and third year, 6 and 6 is same number.
It's the sample size is really small.
Yeah.
But can you look at by their performance? I mean, I don't know how you judge the performance, like whether some student has good understanding, the one actually has positive.
Yeah, that is very difficult. I will show you some other result. And we are doing this project as a part of science, right? Not environmental education. In the environmental education, we teach what to do, right? However, as a science, we teach only the pure science. So, after that, student will think what to do. So, we show this kind of policy option, invest more money in science and technology, that kind of stuff. Then, these are results or overall result. So we cannot say that big difference. Only we can find big difference. Increasing definitely against, definitely for. So student increase the confidence about their idea. However, direction is not always same. Our intention. And also, these are, more detailed t-tests. And I told you, we cannot get any significant difference. However, like this is female, and this is male. For female, we can find significant difference for policy option. And then look at this two. Male and female and male show the opposite response. This is plus, right? This is negative. So if put together, we cannot find any significant difference. And also we ask about just knowledge, which one is greenhouse gas, and then water vapor, oxygen, carbon dioxide, nitrogen, methane. For this one, we can find only the significant difference is water vapor, and then I don't want to show you, however. These are negative. I mean, student made a mistake much more than, pre-test at the post-test for the oxygen and the nitrogen. You know why? We did this kind of experiment using carbon dioxide, oxygen, nitrogen, and then first of all put gas on the water, and then they will shake, and then they will know how solubility is, right? And then after that they put the indicator, and then just change the color means once carbon dioxide solved in the water, they indicate acid, right? So in our camp, they did for the carbon dioxide, oxygen, nitrogen. They should know about different. However, they forgot the result, and then their impression is only carbon dioxide, nitrogen, and then oxygen. I believe that is why we got this kind of, negative result. So this is also, it is very difficult to do something. Result not always our proposed result. Yeah. And then I would like to show you about general questionnaire after the camp. How was the seminar? Like 82% showed very interesting. And then how was the content of seminar? Easy to understand? Yeah, 36%. And then the science interested you? About 68% answered yes. Do you want to be a scientist? 32% definitely. Yeah, and as a matter of fact, we are communication after the camp, and then some of our, finisher will got enter to the, national university in that field. And then, do you have an intention to attend seminar, similar seminar? Yeah. Yeah, and then this is figure I want to show you. Most favorite activity in the science camp. Surely, EdGCM is about nearly 40%. Then that's because our science camp title is to try to NASA's GCM, global simulation. So they gather to do that, even though like 26% most favorite activity as a observation, and then presentation, communication, that kind of stuff. So for the high school student, only one thing is very difficult to concentrate for 3 days. So we should provide several choice in that in our camp. I think that is once you want to design that kind of activity, we should think about this kind of stuff. Yeah. Okay. Do you participate in a science camp and have some influence in the attitude environment program? Yes, very much, 81%. And then these are overall performance. Top is EdGCM. How was the EdGCM simulation? It's more than very close to 80%. So EdGCM is accepted and participant. Yeah, and then this is acknowledgement from EdGCM project, and also we are getting money from the Japan Society for the Promotion of Science. And I will show you pictures. This is with observation. They measure pressure, temperature, humidity, and then they will think about like a relationship between temperature and humidity. And then also, this is ground level, and then in the building, and then top of the building, they will find a pressure difference between ground and then top of the building. And after that, this student try to compute the proper difference, and then they will compare between the observed pressure difference and then theoretical pressure difference. And then for this one, they will learn about property of water. This is water bath, And then this is tiny nest cylinder. If you increase the thermal temperature, you will see the expansion of the water. And then even this kind of simple experiment, they can compute the expansion coefficient by this experiment. And then they will compare the result with the real value. And then also we show several experiments. This is talking about water molecule and then crystal structure. And then this is experiments with the supercooled water. And then this is supercooled water, and then put that kind of water into the ice, and then instantly ice built on that ice. Then this is explaining about greenhouse effect using a pier glass and thermography. And this is to develop the ice crystal. And then using this one is we are teach about 1 mole of the gas. And from that information, we can compute the density of the air. To compute the pressure difference, we need a density of the air. So we can do that kind of experiment too. But in this case, we teach from 1 mole of the air, and we teach average molecular weight. Then they can compute the density of air, and also this kind of experiment. And then for the final project, for each group, for each teacher will assist to discuss about that. So to do that, we need a manpower actually. So for each group, we have 1 teacher and then 1 TA. So for this camp, we are getting money to hire that kind of TA. However, usually it is not easy. Yeah, that's it. It's about 30 minutes, yeah.
So do you have scientists from the field also coming there to discuss with the kids? Mm-hmm. Okay.
And then in Japan, class period is about 50 minutes. So and the college is like 90 minutes in Japan. So it is not easy to to listen or concentrate about 90 minutes. So we plan the very short time period and then put several things.
Yeah.
To refresh their brain.
The Japanese has a mira. The mira that's a Japanese GISS. Mira camp. Japanese has a GISS, right?
Japanese
has their own GISS.
Mira.
Mira.
Mira? Jansen? Mira?
Yeah. So I was wondering if they make any efforts to using doing education this year.
Yeah. Many like meteorological institute also offer this kind of camp. Yes. So there is a pamphlet, so you can find maybe so many.
Yukimasa, how do you select the students from the applications that you get?
From the essay, and then unfortunately, our participant is, first choice. High school students apply for our camp, and then they put first choice, second choice, third choice. That's because, there is selection. And then our camp is very, popular. So we can choose from first choice, right? So if you read the essay, and then if I feel like they want to really do this kind of stuff, so I choose that from essays, based on their motivation.
What are they asked to write an essay about?
Actually, that is general application form.
Okay.
So usually they write what their interest and then their future direction.
Now this goes back to Akira Arikawa. Marvel was built like Akira Arikawa. And Kiyoshi Kawabata, who introduced it here. I don't know whether you know him, he retired recently.
Actually, my best friend is a student from Dr. Kawabata. And then he works for JAXA now.
So he was responsible for us getting into GISS.
And then now I'm studying about Model E. So after go back to Japan, I want to use Model E to do this kind of activity. And if possible, I'd like to send a student to here, or I can invite researcher from here to Japan to give a presentation to the high school student or university student.